Overrepresentation of horizontal and vertical orientation preferences in developing ferret area 17. This is the title of today's paper. Written in 1998 by Chapman and Tobias Bonhoeffer, this paper aims to answer the question if there is an anisotropy of orientation and how it might be affected by individual development. This research specifically focused on ferrets, but has implications for humans as well. To observe the possible changes in orientation preference in development, they conducted this research on 8 developing ferrets and 3 adult ferrets used for comparison. Roughly 32 days after birth, the ferrets represented visual stimuli in the form of square wave gratings. These gratings appeared in different orientations in increments of 45 degrees. Thus, horizontal, vertical, and oblique gratings were shown. The response to those stimuli was observed using optical imaging through the dura. This was done chronically during the developing stages of their early life. On the right, you can see when the recording was done. After signal averaging and normalization to reduce noise and non-orientation specific signals, the optical imaging revealed these single condition activity maps, because they were separated for each of the 4 stimuli. Using vectorial addition of those activity maps resulted in so-called polar maps, which illustrate the orientation-specific activity with color coding. From those polar maps, one can calculate the proportion of cortex that prefers one of the 4 orientation. This is summarized in the orientation preference area, on which a threshold value was used to ensure orientation selectivity. To determine the maturity level of one of those maps, Chapman and Bonhoeffer performed a cross-correlation between the polar map of each development stage and the most mature one of that ferret. The most mature polar map here being the latest one, or the one where nothing changed to the next recording. Thus, a correlation factor of 0 indicates an immature map, while a factor closer to 1 represents a more developed map. In this visualization, you already can see multiple effects, namely that the first ferret has an asynchronous development of the orientation selective areas. At the beginning, the horizontal and vertical preferring areas start to form. This can be seen in the dominance of blue and yellow color-coded areas. Starting at 39 days after birth, the areas color-coded in red and green start to be visible as well. The most matured polar map, being taken 45 days after birth, still shows a majority of yellow and blue, thus horizontal and vertical preferring areas. In contrast to the second ferret, where the development of the orientation preferences was parallel across all presented stimuli. This, again, can be seen by the color proportion across the recorded cortex. Here, in contrast to before, all colors, meaning responses to each orientation, start to be visible at the same time. Additionally, one can see that the orientation activity was present earlier in this ferret than the other one. Although a preference to horizontal and vertical stimuli can be seen, it is far less obvious than in the ferret with the asynchronous development. These and other findings can be seen more clearly in this figure. It illustrates the following. You can see the percentage of the orientation preference area to the observed cortex during the ferret's development. On the right, correlation coefficient is shown also in respect to the postnatal age of the ferret in days. The different markers and line styles show the different stimuli. The black lines show the vertical and horizontal stimuli, while the dashed ones show the oblique ones. The paper illustrates this for all 8 ferrets. However, the results that are continuous overall can be shown with just these 2. These, of course, being the same as those from the previous figure. As you can see, with the difference of those 2 lines, the orientation preference area of this ferret is significantly higher for horizontal and vertical stimuli than oblique ones. The same holds for the second ferret, but as said earlier, to a smaller magnitude. Additionally, the increase of orientation preference with age can also be seen. As stated before, both are with significantly different magnitudes. Interestingly, this magnitude is lower for the ferrets with parallel development. Again, this can be seen across all 8 ferrets, since 4 of them were developing asynchronously and the other 4 developed both orientation preferences in parallel. In conclusion, this means that there is in fact a larger proportion of cortical surface associated to response to horizontal and vertical contours, contrasting to oblique ones, but additionally, the magnitude of this anisotropy is highly different between animals. The finding that there are inter-animal differences of orientation preferring cortex proportions has multiple implications. For starters, the paper argues that better performance on perceptual tasks for horizontal and vertical stimuli than oblique ones, otherwise known as oblique effects, be due to the overrepresentation of horizontal and vertical orientation preferences. Moreover, the variation between individuals of those oblique effects has been also found in humans. These, however, have been attributed to factors like gender or visual experience. Since both males and females showed asynchronous parallel orientation development patterns and the environment was the same across all ferrets, these factors can be ruled out for this study. This, of course, sparks the idea that it might hold for humans as well.